Welcome to the second episode of Kraken Opinions. I'm one of your hosts, Mikey Forsheim,
And I'm Adam Afterhead.
and we're here with Team 11260 Up a Creek Robotics, and they're here to tell you about their robot design, their thoughts on the game, and their thoughts on their new world record. So let's start with that. What do you guys? So when you guys got your world record, what were your thoughts? So, like, what was going through your head? Just in terms of like what this meant for FTC and you guys and your guys' place in it.
I think we were all pretty excited when we got the world record, right? Because none of us were really expecting it because the matches are pretty hard to score, like while you're at the field, certainly in this game, because you can't exactly like count all the freight or whatever. So it was really exciting when we saw we got a 344. I don't think any of us were really expecting it to be that high because our previous match was a 326 or so with the same partner. So we weren't expecting 344. But when we got it, we were all really excited. And we're like, okay, so now we're certainly one of the top teams. So.
And that's great. And you certainly couldn't do it without an amazing robot. So do you want to tell us a little bit about what makes your robot extremely special and world record worthy?
Yeah, so the main part of our robot that I've been really working toward this season is the shared hub, right? So we've seen a lot of robots this year that have been able to do the shared hub like decently well, but our main goal for this season was to make a robot that could do the shared hub as fast as possible and minimize the cycle times as much as we can. And we figured that would be able to score more points than Alliance hub cycles because we thought we could get to the shared hub faster. And so that was our logic there.
Yeah, that's an interesting strategy because we actually chose to go for the top goal of the Alliance hub because, obviously there's more points. So like when you say get there faster, do you just mean like place faster, like with your mechanism, or like is it just distance are you talking about?
I think mostly distance. We could get cycles faster between the shared hub and rather than our own Alliance hub.
Yeah. So like what on your robot are you most proud of?
I mean, so what we say in judging, right, is so our turret is the biggest part, right? But we have a lot of different aspects on our robot that is quite unique. But I would say that mechanically speaking, the turret is certainly the most important part of the robot this year.
And what are you guys using for sensors? Do you have some sort of odometry or you range sensors? Like what's the deal with that?
Yeah, we use a lot of different things. We have two distance sensors in our intake to detect when we get a freight. Then we also have retractable odometry wheels, so we can go over the bars, but also use odometry in both teleop and autonomous when we want to. And then we also have a sensor under our robot to detect the white line, so we can reset the position on our robot if we really want to.
And along with control, I mean, you're looking at videos, your turret is very well coordinated. What do you guys do to make sure that your turret is always angling in the direction that it needs to be in and optimized for certain situations?
So right now we just use set positions. So we just have one position for our shared hub, one for our Alliance hub. So it just goes to 90 degrees for the shared hub and then like minus 90 for the Alliance hub if we're on blue. So that's been our main focus so far, but as we're going in further to the season, we're thinking about using our odometry to turn the turret towards the Alliance and the shared shipping hubs in order to minimize cycle times as much as possible.
Yeah, so as like Sam's driving over, the turret will already be like facing, so if he goes past it, it'll correct itself, so he can just kind of go as fast as possible. But then also when we're intaking, I have like a degree of range of like 70 degrees, I think, for when we're intaking freight. So I can because usually when we're doing the shared hub, we don't really want to pick up balls. So I try my best. And if you look at the 344 match, I accidentally picked up 2 balls, and we're not the best at depositing balls. So I think on our 4th or 5th cycle, we missed both of them because they were both balls. So I'm still trying to get better at not getting balls. And one thing we're trying to look into is using vision instead of me having to do it myself, using vision to turn towards the freight that we want to get.
Yeah, what you were talking about with the balls versus cubes, that's actually an interesting strategy element that we were just starting to talk about. because we realized that when we're starting to fill up the top goal, the balls A take up more space, and B, if we need to start stacking them, we can't exactly do that with balls. So like, is that factored into your decision, or is it just that you have a harder time picking up balls?
Yeah, I think there's a few factors going to our thought process on balls. A big thing just for the Alliance Hub is they're a lot lighter. They're much lighter than the medium or heavyweight cubes. So that's a big part. They're just more valuable in terms of their weight. And yeah, just in terms of the space they take up, because we do get pretty close to filling up our side of the Alliance Hub every match.
Shared hub.
Yeah, I'm sorry, the shared hub. Yes, we get fill that up. So yes, cubes are just generally more optimal.
And with that, I mean, your robot has so many sensors on it, which are great for auto, but do you guys transfer a lot of those over to teleop in terms of like automizing, like picking up freight and delivering freight autonomous?
Yeah, so we've done it in a few different ways. So the thing we use most is the sensor in our intake, right? So we click a button, it goes to the intaking position, and then as soon as it detects a freight, it'll move our arm into like neutral position, ready to be moved into a scoring position. So then we don't have to wait for like a lag time between the driver. So instantly when we pick up a freight, it will automatically move the arm, which signals the driver to go back to the scoring hub. So that's the main sensor we use, but then we also have a lot of different things that Rishi can probably talk about.
And there definitely is a lot of importance surrounding just like shaving those few a half second off here, a half second off there, because each cycle they add up. And if you can shave off half a second each cycle, that means you can probably get an extra 1 or 2 cycles in, which could mean the difference in every game. So I think that's great that you guys do that.
Yeah, we definitely spend a lot of time trying to like optimize our shared hub, like figuring out what the best spot to, because we have a lot of like we can move our turret, we can put our slide out more, we can raise our lift, so we can like deposit from a bunch of different places. So figuring out what the best place to deposit from at the best time and the quickest way to get there is was something that we spent a lot of time on.
Yeah. So 344 is obviously a very impressive score. So how are you guys thinking on improving on that further throughout the season?
Yeah, so there's you go ahead, Rishi.
Okay, I mean we did miss an auto cycle, so just making our auto more consistent. I think we had our 1+5 pretty consistently throughout the match or throughout the whole event, but we'd like to get that up to like a 1+6 consistently, hopefully by states, and that just means more points. And then we were also like, you might have seen like Sam deposit a duck at the end there. I think duck cycles are actually like something that a lot of teams should try out, because like when you clear out the warehouse like we did, like it's a lot faster to get a duck and deposit it than it is to go look for another piece of freight.
Yeah, duck cycles are going to be a big one for improving scores, and then also in our world record match we didn't cap, unlike the overcharge and revamp teams. So that's an extra 30 points we're missing. And then we also did knock a few off of our side of the shared hub in the match. So, yeah, all those things combined can definitely improve the score, though the hubs do get very full, so fitting more on is also a challenge.
Yeah, I think it's really, this game's really interesting because A, the goals are filling up now and we're not even halfway through the season, and B, like we're seeing teams get near to or even clear like the warehouse out. So where we go next is going to be a really interesting discussion.
Yeah, absolutely.
And with that, do you think, like with your score of 344, I mean that's pretty close to our calculated maximum performance for a match. Do you guys think that as we get closer and closer to Worlds, do you think max performance matches will be a thing that will be like completely unbreakable?
It's always hard to say if you're going to get a max score, like in something like Relic Recovery. Obviously, you can max that out, but I don't think this game is quite like that. And the amount of cycles that you miss will certainly be a big factor, and then the filling of the hubs like in a really even way, like especially the shared hub, like there's definitely ways to score like 20 versus like 15 on the hub, so that's probably going to be the biggest differentiator. And then, but other than that, I agree, we're getting very close to maxing out the scores without like there's a lot of nuances though.
Yeah.
I think with like a really good shared bot and really good line spots, like the warehouse empties out pretty fast. So having a robot that can steal from the other side's warehouse is pretty useful. Of course, like you're not always gonna have that opportunity if like you're competing against another shared bot, but I think like the amount of freight in a warehouse is a pretty limiting factor.
I think the biggest thing that you guys definitely show, and a lot of other amazing world ranking teams definitely show, is the fact that they not only can put up super high scores, but the fact that their consistency is definitely there. They're not like, for example, you guys aren't putting up 344 points in a match, but then another match like 120. It's like there's very little luck involved in getting high scores in this game. Whereas other types of games like Skystone, there might be something wrong, or a little flick might tilt your entire tower and things like that. It's just a very calculated game, and I think you guys have done great at it so far.
Well, thank you.
Yeah. Yeah, so we've been able to have really consistent scores, mainly through like autonomous, and then just having a really solid robot mechanically, and then having very consistent software with the ability to have manual adjustments in case errors occur, right? So our lowest scoring match was due to a field reset error in which our autonomous missed a few blocks because the alliance was set up wrong. So we could have replayed the match, but we didn't really feel the need to. So yeah, so it's really definitely possible to be very consistent in this game, and I think it really comes down to that robot mechanical performance.
Yeah. So what are you guys looking for like in the area of awards this year?
Yeah, so we're always shooting for Inspire, right? And so in our first qualifier, we won the Inspire award, and then
Nice.
and then this tournament we won the Control award, and then hopefully at state we can get the Inspire again, and then I mean Worlds is always a crazy gamble, so I don't think anybody's guaranteed to get any awards, but we're obviously shooting for something there.
Right.
Yeah, it'd be amazing to win an award at Worlds.
Mm-hmm. Yeah, we're also trying for Inspire, of course, but yeah, we've gotten, I think, second Inspired twice now, but we're working on getting our outreach up there. We got Control, we got Think. Yeah.
Nice.
What would you guys say is like, if there was one thing that like your team mostly focused on, because you guys are very solid in both mechanical and software, and obviously outreach if you guys are winning Inspire, what would you guys say is your biggest asset in terms of just personnel and just ability to do well?
That's a hard one. We have a lot of really great mentors on our team that are able to support us, right? And so we've got software mentors, mechanical mentors, and outreach mentors that are able to help us. Like a lot of it's teaching new students, right, how to become really adept at using like whatever like CAD software, and then like teaching them the framework of our current coding, and then like also giving connections with our current sponsors and like outreach partners, sort of. So that's certainly one of the ways that we're able to be consistent, and they're very valuable.
And mentors are definitely very important in any team. Just making sure that there's always someone who like you can always not exactly fall back on, but look to for advice.
Yeah, absolutely.
It's definitely important.
You mentioned CAD software. What are you guys doing for CAD? Like what software are you using? You know, all that sort of stuff.
Yeah, so for CAD we use Onshape.
Oh, us too.
Yeah. we really like the online collaboration aspect of
Yeah.
being able to share documents and work on them
Mhm.
with other people when we're not in the building together.
Yeah.
So we've had a lot of success with that.
Yeah, Onshape is excellent for FTC. I think the best part for our team specifically is that we're able to use computers at both our headquarters, our like robot place, and then also our house. So people can work on CAD models at their own homes and then also work on them at the headquarters, and then we can make changes, and then also sharing them with other teammates and mentors. Uh, and then also sharing parts so that we can 3D print them on multiple different printers so that we can get things done more quickly is also really important.
And how much planning? So do you guys completely CAD your robot before you start building, or do you kind of, if you a certain problem arises, do you guys design a solution, or do you guys just completely like build now, CAD later kind of thing?
Yeah, so our team's evolved over the past 4 years or so. We started out as sort of like a build now, CAD later kind of a team, and then we slowly sort of moved into a CAD now, build after sort of a team, and it's really been a big difference in our team's ability to build not only quickly but effectively, right? So we tend to make CAD prototypes first. So we CAD something, prototype it, make it initially, and then see how well it works. And then we make another design of the same thing in CAD, more refined, like change whatever we need based on the prototype. And then we'll CAD the whole robot basically. And then after we CAD the whole robot, then we'll build it, is usually how it goes. Or we'll CAD parts of the robot and then build it, and then CAD another part of the robot and then build it. So that's our design process.
Yeah, just the kind of like prototype, build prototype, and then like you just like combine everything together, or do you just like test like certain subsystems like together separately, and then, or like does your complete robot just like go together at the same time, and then like you work out any differences, or does that all come CAD together at the beginning?
Yeah, so normally we start out by CADing each subsystem individually, and that's how we prototype, right? So like this year we had a bunch of different drivetrain designs that we were able to prototype, CAD up, build, and then test out. And then after that, well, I guess while that was happening, actually, we're able to look at the designs for different like lifting mechanisms, intaking mechanisms, and such. So once we have all of our like initial design ideas, then we're able to CAD it all together and then build it after. So we sort of do each subsystem individually and then put it all together into one final model before we build the final robot.
And on that custom drivetrain, what would you say was like, when making that, the most important things to consider for maybe rookie teams who want to design their first drivetrain, or even more experienced teams who are just looking for more things to consider for this year?
Yeah, I mean, there's not a whole lot to consider when building the drivetrain. Well, I guess, but that's not true, actually. There's a lot to consider. So there's like motor placement, right? And then you've got like wheels, and then, but you also have to consider like odometry pods. And then one of the biggest things that we try to take into consideration is electronics that sometimes we sort of forget about, right? Like we have to figure out where our expansion hubs and our batteries going to go. And so especially this year, it's been a lot more difficult because we're going with a smaller robot design. So there's not as much space to fit in those hubs. So we designed our chassis specifically to be wide enough to fit an expansion hub or remote control hub in between our frame. And then we also like designed our motor placement so that they could nest together, right? Like you do for the thinner designs this year. So, I mean, those are sort of the things you have to consider when building a chassis, but I think as long as you make a design that works, you can't really go wrong.
That's fair. Well, this has been a great interview. Thank you guys so much for your time. Team 11260, I hope you guys do great this year, greater than you are doing right now. If that's even possible, you guys are doing amazing. But best of luck to you, and thank you so much.